Hi students, in this video we will be learning about random variables. Coming to these random variables, one of the most important topic in communication systems, this random variables and random process will combinedly coming 4 to 6 marks. Once if we analyze this random variables, random process, then we can see the noise analysis of analog communication as well as noise analysis of digital communication, of course called probability of error calculations. What is that? Probability of error calculations. Coming to this random variable analysis, this is a concept of a probability theory. If you take the input of a receiver, what is the input of the receiver? The modulated signal will come, that is our signal, along with the disturbance, means noise also will come. So the input of a receiver is nothing but our information plus noise. Our information means it will have some mathematical expression. Noise means it does not have any mathematical expression. Are you getting my point or not? So for analyzing that, we come across with this concept of random variables. Later these random variables are varying with time. Those are called random process. Let me start with a simple example, then we will forward. I think all of you know the experiment of tossing a coin twice. What I'm taking the experiment? The experiment is tossing a coin twice. If you toss the coin twice, what is the possible outcomes, sir? The total possible outcomes is called sample space. The total possible outcomes is called sample space. What are the possible outcomes, sir? Both may be head and tail, maybe tail and head, maybe both are tails. So each and every outcome is called one event. Happening both are head is one event. Happening head and tail is one event, like that. The total outcomes in that experiment, total outcomes itself is called sample space. I denoted with S. Here, let's see how I define the random variable. Here, a random variable X is defined. A random variable, always random variables are denoted with the capital letters. A random variable X is defined in such a manner that it indicates the number of heads in the experiment of tossing a coin. Let X be a random variable which is indicating the number of heads in the experiment of tossing a coin twice. So if I toss the coin twice, this is the outcomes. Then what is the random variable value? Number of heads. Here 2, here 1, here 1, here 0. That itself is called the random variable. Here how I define the random variable X I told. Denoting the number of heads in that experiment of tossing a coin twice. Always in solving of the random variable problems, the first most important point all the students has to learn that what is the values for that random variable. Sometimes he will tell you, let X be a random variable which is choosing positive odd numbers less than 100. The meaning is the random variable values are 1, 3, 5, 7, 9, 11, like that. So, and understanding the first point for solving of any problem or any concept, you need to understand what is the possible values for random variable. Suppose if it is a continuous, what is the range of that random variable? The two are the most important points. Clear? Yeah. Here, coming to the definition of a random variable, I can say that assigning of real numbers to each and every outcome of a sample space. Assigning real numbers to each and every outcome of a sample space is called random variable. Assigning of real numbers to each and every outcome of a sample space is called random variable. Of course, here this random variable is a discrete random variable. Discrete random variable. Why it is a discrete, sir? Because this random variable is taking only integer values. This random variable is taking only integer values. If the random variable is taking only the integer values, that is called a discrete random variable. Why? Because here x value cannot be 0.5, cannot be 0.7, cannot be 0.9, cannot be 1.1 like that. Why? Because here x value becoming a 0.7 means the number of heads should be 0.7. The number of heads should be 0.7 or the number of heads should be 0.5 like that. So that's why that is not at all possible. So this random variable becoming non-integer is not possible. So it called as a discrete random variable. Discrete random variables means it takes integer. Maybe negative values also, -1, -2, -3. Those also will be there. But integers. If the random variable is taking only integer values, discrete random variable. Now come back. Here we discussed about the discrete. Now what about the continuous? A random variable is said to be CRV, that is continuous random variable, if it is taking all possibles in the range. If it is taking all possible values in that range. For example, I am defining a continuous random variable y. I am defining a continuous random variable y which is existed in the range 0 to 10. Which is existed in the range 0 to 10. The meaning is that y is taking all possible values between 0 and 10. 0, 0.1, 0.2 and so on up to 10. Are you getting my point or not? If the random variable is taking all possible values in the given range, that is called continuous random variable. Only integer values, that itself is called discrete random variable. Integer values discrete, all possible values continuous. For example, they defined a discrete random variable in the range, a discrete random variable in the range 0 to 10, meaning is, what's the meaning of that? The x value is 0, 1, 2, 3, like that integers you have to take. Continuous random variable means all possibilities from 0 to 10. If it is a continuous random variable, what is the total possibilities? If it is a continuous random variable, what are the total possible values from 0 to 10? 0, 0.1, 0.2 and so on up to 10 means how many possibilities are? Total possible values are infinity. If it is a continuous random variable, infinite possibilities will be there. What is the formula for probability? What is the formula for probability, sir? Probability is nothing but number of favorable chances. Number of favorable chances by, I can say, total chances. Number of favorable chances by total chances is called probability. Now, suppose for continuous random variable I am discussing. I want to calculate the probability of y becoming 2. Y becoming 2 is 1 chance out of infinity. Then how much you will get? 0. Means the probability of a continuous random variable at a single point is not defined. The probability of a continuous random variable at a single point is not defined. Then how defined, sir? How it is defined, sir? It is defined always in the range. That is, what is the probability of y becoming in between 0 to 1? or in between 0 to 5 or 2 to 5 or 3 to 5. Like always, whenever we are discussing the probability of a continuous random variable in the range, at a single point its value 0, that is not defined. Let's see the probability of a discrete random variable at a single point. This is a discrete. What is the probability of discrete random variable I am taking? What is the probability of x becoming 1 in this experiment? X becoming 1, there are 2 chances are there out of 4. So it is 1 by 2 as existed. Probability of a discrete random variable at a single point existed, but probability of a discrete random variable at a single point existed, but the probability of a continuous random variable at a single point not existed. Now, for analyzing this, we are having different functions are there. First one is probability mass function, probability distribution function, probability density function. What are the three? We are having 3 functions. First one is probability mass function. In the short form we can call as a PMF. Second one is called probability distribution function. This is also called cumulative distribution function. Cumulative distribution function. So that's why it is called as CDF, not the PDF. PDF is different. This is a PDF. What is the third one we are having is probability density function. This probability density function we are calling as PDF. Probability mass function, distribution function, density function. PMF, CDF, PDF. Especially first one for discrete, last one for continuous. This you can use for anything. Clear?